Hi boys, and welcome to drawing an electrolytic cell. So today we're going to mess around with the idea of a molten sodium chloride cell. So if we look at where those things are on our electrochemical series, we've got a whole bunch of other junk in the middle, and then up here we've got chlorine gas plus 2 electrons going to chloride ions. Yes. Woohoo! So just a reminder, with electrolysis, we're going up the hill. So we've got this reacting with this, right? This is going to be the reverse reaction. So in this case, this is going to be our reduction of the metal, and this is going to be our oxidation up here. So when we draw the cell, we only use one container in this particular case, and we'll want to have electrodes that are inert, right? Ones that are not going to react with what we've got in here. So I'm going to choose a platinum electrode, right? Because it's a very, very non-reactive metal. We've got platinum electrodes in there. Now, we're going to connect this up to a battery, right? The way we represent a battery is like this. And what we need to figure out is which terminal's which. So this is our negative terminal, this is our positive, which means that if this is our negative terminal, our electrode that is connected up to this is the negative electrode, right? The electrons are all getting pushed down, bam, 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 push, 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 onto this electrode, right? There's all these electrons going on down here, which means they're also getting ripped off of this one. So the electrons here are moving up and away towards the battery in this case. So what ramification does this have? Well, makes that the positive electrode to start with. But if we look at our different equations and what we've got going, if we have electrons being pushed down onto there, we are pushing an electron onto the sodium ions that are in solution. So this is molten sodium. It only has sodium and chloride ions floating around together in a liquid. There is no water in this situation at all, because if there was water, we'd have competition at electrodes, and we'll talk about that in another video. But if I've got sodiums and I've got chlorines, right, then I'm going to have all the things that are positive, like the sodiums, go towards those electrons. They are all going to want to swim their way over and find those electrons. And what we're going to have is the sodium ions plus the electrons reacting together to form the sodium metal solid. And this is the reduction. And reduction, remember, always happens at the cathode. So now compared to our galvanic cell, where our cathode's positive, our cathode is now negative. And you can see why when you think about the way the electrons are flowing. The electrons always flow from anode to cathode, always, in every case. But the way the reactions happen change a little bit depending on whether they're spontaneous or non-spontaneous. So if we look at the reaction on this side, we know we've got electrons getting taken away. And we've got these two chloride ions with electrons to spare just kicking around. And they're going to rip the electrons off those chlorines when they come into contact with that electrode. And they are going to turn them into the chlorine gas and the two electrons that are required to move back here. So they move up, down onto here, and then they get picked up by here on this side, right? And the battery just keeps pushing and pushing and pushing. And what we make is chlorine gas and sodium metal in this particular case. If you have any questions, oh, whoops, I forgot. That means this is the oxidation. and it is also the anode. Because oxidation is always at the anode and reduction is always cathode. Another thing that I come across do not panic. I can't remember what panic stands for. Let me think about that for a minute. Negative is cathode. Positive is anode. So, if ever you get stuck, and this only works for an electrolytic cell, don't do what I just did and panic because you can't remember. The positive electrode is the anode and the negative electrode is the cathode, right? So don't panic when drawing electrolytic cells. You should have this fine.